everyone, today we are going to be doing some practice problems involving both the triangle sum theorem and the exterior angle theorem. So looking at number 9, I see that I have this exterior angle, and I know that the exterior angle theorem says that my exterior angle is equal to the two interior angles that it does not touch, that it is not adjacent to. So 84 plus 10x minus 3. As soon as we have our setup, it becomes a solve for x problem. So I collect all of my like terms, all my x's on one side and everything else on the other side. So 21x minus 10x gets me 11x. 84 minus 4 is 80, minus another 3 is 77. Last step is to divide out this 11, so x is going to equal 7 for this problem. Similar setup over here on the right. I have an exterior angle. I know that 11x plus 3 is equal to the two interior angles that it does not touch added together. So 11x plus 3 equals 85 plus 5x minus 10. Once we are here again, it turns into a combine my x's, get them on one side, and combine my numbers, get them on the other side. So 85 minus 10 is 75, minus 3 is 72. Last step is to undo that times 6 by dividing 6 on both sides, so x is going to equal 12 for this problem. And then we have a slight variation of this sort of exterior angle problem. Notice this time I am finding the measure of angle EFD. So in order to do that, I first need to solve for x. As soon as I solve for x, then I plug it in for the measure of EFD, and then I solve from there. But again, I have exterior angle, and so I know that 5x plus 14 is equal to the two angles it does not touch added together. So 3x minus 10 plus 46. And again, we're going to go through and collect x's on one side. So 5x minus 3x is 2x. And collect numbers on the other. So 46 minus 14 is 32. Minus another 10 is 22. Last step is I divide out my 2 to get x all alone, so x is equal to 11. Now, do not stop here. This is not our answer because we need to actually find the measure of angle EFD. So our next step is to take this and now substitute it in to the expression for the measure of angle EFD, which is 3x minus 10. So I'm going to take this, plug in here. So 3 times 11 minus 10. Well, 3 times 11 is 33 minus 10 equals 23. Now that is my answer, 23 degrees specifically. So just be sure you're double checking what you want to solve for. For this problem, we're going to go back to solving just for x. And now we are no longer dealing with exterior angles, rather we are dealing with all interior angles. And so this is going to be when we have to utilize the triangle sum theorem. The triangle sum theorem says that all three angles in a triangle must add up to 180 degrees. So that's exactly what I'm going to do to start this problem. I'm going to take all three of my angles and add them up and set them equal to 180 degrees. And now I go through and combine my like terms. So 9x plus 16x gets me 25x's. And then 80 plus 4 minus 4, well, those are just going to cancel each other out. So I'm left with plus 80 equals 180. Now I want to get the x's alone. So I'm going to subtract 80 from both sides. So 25x equals 180 minus 80 is just 100. And my last step is to divide out 25 on both sides. And I'm left with x equals 4. Now we get some challenge problems out of this. So everything I've shown you up to this point has been one step aside for when we had to solve for the angle measure. This was 2 steps. With something like this, I cannot jump right in and just figure out this angle here right off the bat. I first have to figure out this angle here. And we'll see why that's important in a minute. So again, I'm going to use the Triangle Sum Theorem, and I'm going to call this angle x for right now. So I know that 30 plus 40 plus x must equal 180. Well, 30 plus 40 is 70. Still have plus x, and I still have equals 180. I subtract my 70 from both sides, so I know that my angle x equals 110 degrees. Well, how does that help us? Well, we know, hopefully, that these two angles here are vertical angles. And vertical angles are congruent, which means the same or equal. So if x is 110 degrees, then I know this angle must be 110 degrees as well. And then once I get that part set up, now I know that all 3 angles in this triangle, so 110 plus 25 plus question mark, must equal 180 degrees by the Triangle Sum Theorem once again. Now once I have this set up, I just go through and solve. So 135 plus question mark equals 180. Subtract 135 from both sides, and so we get question mark, our missing angle, equals 45 degrees. Now with this example here, again, I have a couple of steps I need to do first before I can jump in and solve for x. So first thing I notice is that these 2 angles right here are vertical angles. So if my angle out here is x plus 74, I know my angle in here must be x plus 74. Likewise, with this angle down here, 73 degrees, I have vertical angles here. So if this is 73 degrees, I know that this angle must also be 73 degrees. Now I know all 3 angles inside this triangle. As soon as I know all 3 of these angles, the Triangle Sum Theorem tells me I can add them up, and when I do that, they must equal, yep, you guessed it, 180 degrees. And now we go through and we combine our like terms just like normal. So x and x gets me 2x, and 74 plus 73 plus 37 gets me 184. And then I still am equal to 180 degrees because I have not touched that. Now I subtract 184 from both sides. I'm left with 2x equals -4 this time. Last step is to divide out my 2. So I get x equals -2. Now you might be saying to yourself, that doesn't make any sense. How can x be a negative angle measure? We don't really know about angle measures. We haven't worked with that before. We haven't seen it before. Here's the thing. This is not an angle measure. This is just the value of x. So when I plug x back in here and over here, I still get positive angle measures for all of my interior angles. So that's okay. This is still a good answer, even though we see it as a negative. And one more example here. This one we have a few steps we have to do before we can find this question mark angle here. First thing I'm noticing is that I have vertical angles between those two. I'm given 62 degrees down here, and I know if I can find this angle measure, well, then I'm going to be able to use the Triangle Sum Theorem to get this angle, which will then give me this angle. Now, in order to get this first angle, I can use that in conjunction with 52 degrees and this angle measure down here, because all of these are supplementary. They form a line. And before I can even do that, I have to first find what this angle measure is. And if I know this angle measure in here, that's going to be very useful because, again, I have a triangle sum theorem problem. And I can figure that angle out because these two are vertical angles. So this angle must be 85 degrees. And now I go through and I just work through that process in the opposite direction. So I know 85 plus 37 plus, we'll call this x1, equals 180. So 85 plus 37 is 122 plus x1 equals 180. Subtract my 122. And so I get 58 degrees for x1. And so I know that x1 is 58. This diagram's going to get really busy. I apologize. But now I can solve for the second step. So I know 58 plus 52 plus, I'm going to say x2, all added up must equal 180 degrees because they form this line right here. So that's this angle, 52, and this angle in here. I'm adding all of those up to find this angle in here. So 58 plus 52 is 110 plus x2 equals 180. Subtract 110 from both sides. So x2 is going to equal 70 degrees. So this guy right here is 70 degrees. Now I can look at this triangle here and again use the triangle sum theorem. So I can say 70 degrees plus 62 degrees plus x3 must equal 180. So 70 plus 62 is 132, plus x3 is 180. I'm going to subtract 132 from both sides, and we're going to get x3 to equal 48 degrees. So that's this angle right in here. Thankfully, our last step is just to say that question mark equals 48 degrees because, as we said in the beginning, both of these angles are vertical angles, and we know that vertical angles are congruent. So those are some example problems that are a little bit more involved than what we've been doing with triangle sum theorem and exterior angle theorem. Thank you for watching. I hope you have a great day, and let me know if you have any questions. Bye!